Advanced Math, Set 104, Arithmetic Series, and Geometric Series. Okay, so a series is the indicated sum of a sequence. So far we've been doing sequences where we've got a list of numbers, and the list of numbers is usually separated by commas, and it's a common sum in between. So that's a series, or that's what's called a sequence. And then a series is those same numbers but separated by the plus sign. An arithmetic series is an arithmetic sequence with a plus sign in between each entry. It's indicated by an S, and S sub 4 would have 4 terms that are added together. So the answer would be 62 when you add them all together. S sub 6 would be 6 terms, and S sub n would include n terms. So in order to figure out the formula for the sum of n terms, we'll just take an example. So we'll take this series right here, and if you notice, if you take the first and the last term, 11 and 32, and add them together, we get 43. Then if you take the second and the second to the last, 14 plus 29, you're also going to get 43. And as you go on down the list, 17 plus 26 is also equal to 43, and 20 plus 23 is also going to be equal to 43. So we end up having 4 43s. So the sum of all of these numbers is going to be 4 times 43. So in order to develop a formula for this, we find that we have 8 terms, and since we paired each term with another term, we're dividing it by 2. So 8 terms divided by 2 gives us 4. And the way we got the 43 was we just took the first term plus the last term. So the formula for a particular sum of n terms is going to be S sub n equals a sub 1 plus a sub n, the first term plus the last term, multiplied by n over 2, the number of terms divided by 2. Now this works for even numbers. We'll check and make sure that it works for odd numbers as well. So here we've got 9 terms instead of 8, and when we add those all together, we see that it's 207. So we'll double check and make sure that our sum is going to, or make sure that our formula works for this as well. So when I take 11 and 35, I get 46. And notice I get that for everything, but I'm left with that 23 in the middle. So we've got 9 terms. Remember our n divided by 2. 9 terms divided by 2, and then we'll multiply that by the first plus the last term, which is 46. So we get 4.5 times 46, and that gives us 207, which is what you get if you actually literally add the terms together. So the formula works for even and odd. So we'll do an example here. An arithmetic sequence has a first term of -10 and a common difference of +20. Use the first 4 terms of this sequence to write a series and develop the formula for the sum. Then use the formula to find the sum of the first 11 terms of the sequence. So kind of a lot of things to do here, but we'll start. We've got 4, because it says use the first 4 terms of the sequence to write a series and develop the formula. So here's our sequence, and the series is going to have the plus signs in between, which I didn't have here. So we just need plus signs in between to get that series. So our first term and our last term is going to be 40. So S sub 4 is going to be -10 plus 50 times 4 divided by 2, 4 being the number of terms divided by 2. So our sum is going to be 80. So remember, S sub n is the first term plus the last term times the number of terms divided by 2. So we are needing to find the sum of the first 11 terms. So this is a little bit tricky because we know the first term. We know the first term is negative 10. We don't know the last term for a sub 11, but we do know it would be 11 terms divided by 2. So we need to figure out how to find a sub 11. So in order to do that, we're going to go back a little bit to previous lesson, and just as a reminder, our first term, a sub 1, is negative 10, a sub 2 would be positive 10, next term would be positive 30, a sub 4 is positive 50. So if a sub 1 is negative 10, a sub 2 is going to be negative 10 plus 20, and a sub 3 is going to be a sub 1 plus 2 times 20, so a sub 11 is going to be a sub 1 plus 10 times 20, because you just take your n, subtract 1, and multiply by 20. So our a sub 1 again is negative 10, so it's negative 10 plus 200 gives us 190. So now we know our 11th term is going to be 190. So negative 10 plus 190 times 11 over 2. So it's 180 times 11 over 2. 2 goes into 180 90 times. So 90 times 11 is 990. So the sum of the first 11 terms is 990. Now we're going to take a look at a geometric series. So a geometric series is just like an arithmetic series, except that we are using a geometric sequence instead of an arithmetic. And in a geometric series, if you remember, you're multiplying by the same number every time. So your first term is a sub 1, your second term is a sub 1 times r, then a sub 1 times r squared, a sub 1 times r cubed, all the way up to a sub 1 times r to the n minus 1. If we go back one more, the term n minus 1 is going to be a sub 1 times r to the n minus 2, which is going to come in handy when we are developing the formula. So the sum of all of these, or the series, we put a plus sign in between all of these. And now we'll go about developing the formula. So the first thing when we're developing the formula is we're going to multiply everything by r. So we're going to multiply the left side by r and the right side by r. On the right side, multiplying by r really just kind of takes everything and shifts it over. So a sub 1 times r, a sub 1 r squared, and so on, all the way up until you get a sub 1 times r to the n. So now what we're going to do in order to get all of these to drop out so that we don't have all of these repeating factors in the middle is we're going to multiply that by a negative 1. Because when we multiply that by a negative 1, then all of these middle terms are going to pair up and they're going to subtract. So what we end up with is, that went a little bit further than I wanted it to. Hang on, let me just back up a little bit. So all of these are going to pair up, and eventually they're going to drop out. So what we end up with is s sub n minus r times s sub n. Oh, well, let's just put these in here for just a second. So here's our first series, and then here's our second series. So minus r times s sub n, and then when we subtract, a sub 1 minus a sub 1 r minus a sub 1 r is going to drop out. So we're going to be left with so when we subtract here, we're going to be left with s sub n minus r s sub n is equal to a sub 1, and then everything in the middle is going to drop out, and we'll be left with minus a sub 1 times r to the nth power. Okay, it's a little bit confusing. Hopefully that made sense. So now we're just going to simplify this a little bit, and we're going to pull out an s sub n on the left side. When we pull out s sub n on the left side, we get 1 minus r. Then on the right side, we can pull out an a sub 1. So when we pull out a sub 1, we get 1 minus r sub n. And then to solve for S sub n, because we're trying to find a formula for the sum of the series, or for the series, excuse me, we divide by 1 minus r. So our formula becomes S sub n equals a sub 1 times 1 minus r to the nth power minus 1, or divided by 1 minus r. So we'll just do another example. Develop the formula. Develop a formula for the sum of the first n terms in a geometric series, and use the formula to find the sum of the first 9 terms in a geometric series whose first term is -8 and whose common ratio is -2. So again, the series is going to look like this. S sub n equals a sub 1 plus a sub 1r plus a sub 1r squared, and so on, up to a sub 1 r to the n minus 1. And then the term that's right before that is a sub 1 times r to the n minus 2. And then we're going to multiply that by essentially a negative r. So we end up with minus a1 sub r minus a1 minus a sub 1r minus a sub 1r squared minus a sub 1r cubed, and we go all the way till we get to minus a sub rn. When we add that together, all of those middle terms are going to drop out, and you're left with s sub n minus r s sub n equals a sub 1 minus a sub 1 times r to the nth power. Now we're just going to divide, pull out an s sub n on the left, pull out an a sub 1 on the right, and then divide by 1 minus r. So there's our formula. And now we're going to use the formula, find the sum of the first 9 terms in a geometric series whose first term is -8, whose common ratio is -2. So we know r is -2, a sub 1 is -8, and n is 9. So s sub 9 equals -8 times 1 minus -2 to the 9th power all over 1 minus -2. We're just taking and plugging in. So from here, we get -8. -2 to the 9th power is going to be -512. So we have 1 minus -512 over 3. We add 512 to 1. We end up with -8 times 513 over 3. And that is -1,368. Okay, find the sum of the first 10 terms of the geometric series in the preceding example. So now we're just doing 10 terms. So if you remember, our a sub 1 was -8, r was -2, and now n is going to be 10. So our formula is s sub n equals a sub 1 times 1 minus r to the nth power all over 1 minus r. So s sub 10 equals -8 times 1 minus -2 to the 10th power all over 1 minus -2. So we have -8 times 1 minus 1024 all over 3. So -8 times -1023 over 3 gives us 2,728. So something just to take note of in this geometric series, notice that the 10th term, or the sum of the first 10 terms, was a positive number, and the sum of the first 9 terms was a negative number. You can get that in a geometric series where it alternates positive, negative, because of the multiplying when you're multiplying by a negative number. So interesting thing. Anyway, there you go.